Okay, here we have question 9. We're starting off with a curve with the equation of y equals inverse sine of 2x. So you should have memorized the graph of y equals inverse sine of x, okay? If you haven't memorized it, then it is possible to work it out from the graph of y equals sine x and thinking about the graph of an inverse function, but it is advisable to learn all the graphs you're supposed to know. But because we haven't got an x here, we've got a 2x, then that's going to cause a transformation to the graph, okay? So we've multiplied by 2, decide whether it's inside or outside, decide the transformation, and the fact that there are halves and minus a halves going on here actually should confirm your ideas about what the transformation is. So we have got to now think about what has changed or not changed from the graph that you know, and think about, okay, what are these values here and here? And it's actually this value here that will get you your first mark. Okay, then for part B, we've got to rearrange this to this. It's a show that question. It's just 1 mark. In fact, the real role of this is to help you get started on B2. Okay, but in rearranging this, you just need to think, what do I need to make to both sides to make an inverse sine go away? Okay, and then what do I have to do after that? So getting to here convincingly, we only need 1 line in between the two, but it needs to be the correct one, and you need to have not cheated. So make sure you're clear about what stages of rearrangement you're going through. The first thing to deal with is to get rid of the inverse sine by doing something to both sides. Okay, b dotted 2. All right, so this is a re-entry point because they set you up here. So given that x equals a half sine y, so that was the finishing point from b dotted 1. Okay, given that x equals a half sine y, we've got to find dx by dy in terms of y. Well, that's 1 mark because it's very easy if you know how to differentiate a sine. We've got x and y the opposite way round from usual. Okay, which is why the answer we're getting is dx by dy, not dy by dx. So this is just ordinary differentiation, it's just that the letters have to be swapped. Okay, so the whole of B actually was there to set you up for part C, because for part C we've got to find dy by dx, and we've got to express it like this. Well, the first step is taking your dx by dy, okay, and going from dx by dy to dy by dx. You could say it's flipped. We've done the reciprocal of it. So the first mark's going to be very easy. You're just going to take your answer to b dotted 2 and do the reciprocal of it. And then you've got to explain why it looks like this. Now, we did a set piece of this in your notes, but the real thing you're going to have to work on is when you differentiate this, you're going to get cos y in the answer. So how do we express cos y, okay, in terms of x's? There aren't any y's, let alone cos y's in the answer here. So what do we know about cos y? Well, we know what sine y is. Here's a sine y. So I could make sine y the subject of that formula. If I know what sine y is, and I know something about sine squared y plus cos squared y and what that equals, then I can substitute what I know sine y is into that part there, okay? And then I can make this cos y the subject of the formula, so that the cos y that I get in my dx by dy, okay, I can replace by something that will come out in terms of x is what I want. And then with a little bit of not making any algebraic mistakes, a bit of valid algebra, you know that you're trying to rearrange it into that expression. So these 4 marks, okay, they probably are the hardest 4 marks on the paper, but they're not impossible, especially if you really followed the set piece that we did in your notes when we had an example a little bit like this.